Hello everyone. Uh, Now we'll start with uh, 4.1 and today we'll discuss 4.1 and 2, 1 and 2 rather, and after I finish I'll assign the homework as well. So today, as you know, you don't have a live session. I will only have this lectures for the videos. So what I would recommend once again, just before going for my videos from the book, look for the contents of the section 4.1 and 4.2. Just briefly go over those, then come and see my video, and then of course see the PPTX file on 4.1 and 2. And maybe you can practice those problems, or you can always go back to your book and see the workout problems and then practice a couple of more from the exercise. Okay, so from 4.1 we want to know how a polynomial actually looks. How does this work? What are the properties of this and all that? Okay, so let's start with an example. So let's say our polynomial is 4x cubed minus half x squared minus 7. As you can see, we have three different terms here. So we say it's a polynomial. Okay. Now, from this, we want to find different properties. Okay. So, if we have a polynomial in this format, x to the n plus a n minus 1 x to the n minus dot 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 a1 x plus a naught. As you can see, the subscript of a is actually going down, and the exponent of x is also going down. Okay. Now, from this, if it's the general format, of course, from this we can actually find the leading coefficient and the degree of a polynomial. Just a quick reminder, if you remember, I did say whenever you see a polynomial, straight away you can say the domain of that is the set of all real numbers. Okay, just a quick reminder. So whenever you see a polynomial, if the question says what's the domain of that, straight away say, hey, this is for this, the domain is from negative infinity to infinity, or the set of all real numbers. Okay. Okay. So if you have a polynomial of this format, you can always say that n is the degree. Oops, sorry. N is the degree of your polynomial. Okay. Now, what does this n signify, or where can you actually see this? As you can see, it's the highest exponent in your polynomial. The highest exponent in your polynomial is called the degree. Okay. So, if we just quickly go back to our problem, can you see the highest exponent here? And if you are not wrong, your intuition should say this is the highest exponent, right? 3. So we'll say for that problem, for A, we'll say the degree of A is 3, right? Okay. And the term with the highest exponent, or the degree rather, we'll say that is the leading term. Okay, so the leading term, I'll write it LT, that's the leading term. So the intuition should say that's 4x cubed. Okay, now what's the leading coefficient? So whatever your leading term is, as our polynomial is in terms of x, as you can see, whatever you have with that is your leading coefficient. So the leading coefficient here is 4, right? So these are a couple of informations you can get from a polynomial. Okay, and as you can see, we have a naught here. That means we'll have, or we might have, it doesn't necessarily mean that we need to have that, but we might have a term without x, our variable. X is our variable on this occasion. It could be a possibility to have a term without x. We say that's a constant term, and for a problem, the constant term is 7. You can write that as well. Constant term, that is -7. It's negative because our ideal format says we'll actually consider everything positive so that it's easier to compare. Okay. Okay. Now, excuse me. Now, we want to see different examples of this. So let's try the next example. Let's say this one is h of x, and in the numerator we have x cubed minus 2, and in the denominator we have x to the 4 plus 1. Now, what's the degree of this? First of all, your question should be, is this a polynomial? And if you look at the terms you have, or rather the look at the numerator and denominator separately. If you look at this is definitely a polynomial, no doubt about that. This guy is a polynomial as well, but this is basically the ratio of that two. Those two other. So this is not exactly a polynomial. Okay, this is, we call this a fraction, if you remember, right? So this is not even a polynomial. What happens if we have a function like this? Okay, that's just a 9. So we can still call it polynomial, although we can actually define it as monomial because we have a single term here. If we have 2 terms, we might define it as binomial. If we have 3 terms, we can say trinomials. Whatever it is, all of these are polynomials, right? So this is, we might say that it's also a polynomial, but on this occasion, our degree, as you can see, the highest term with the variable x is actually x to the 0, right? We can actually rewrite this as x to the 0, 9 times x to the 0, because anything to the 0 is actually 1. So we can actually rewrite this 9 as 9 times x to the 0, and that's the leading term, or rather the highest exponent. So we'll say the degree of that is 0, right? And the leading term is 9, and also the constant term is 9. Can you see that? Because we have defined constant term, the term without the variable, right? Where there is no x. So this could be another format which you can define as polynomials, right? Okay, Now, let's go and see one more type of function, which is called power function, which you'll see in the next video.